All right. All right, welcome to Monday, CS 107. I just kind of walked around. It sounds like the assignment is going okay so far. Hopefully you guys are doing all right on it. The deadline, or the due date rather, is tonight at midnight, 11:59, I think. If you want the on-time bonus. Now, we are giving you an extension of 2 days kind of by default if you want to hand it in by Wednesday. Technically, it's still late, but it is, we're not going to give you the on-time bonus, but we don't take any other points off. So that's how that works. Okay, so hopefully that's all right. Tomorrow morning, assignment 2 will come out. So like I said, you get on the train in 107 and you just keep on going. It doesn't really stop. All right, today, we are going to talk about pointers and arrays, and then I'm going to kind of introduce them and talk about details of pointers versus arrays and how they're the same and how they're different, and we're going to get through some of those details. At the end, if we have time right at the end, I'm going to talk about some interesting features of, like, what do you know about arrays, such that you can deal with them when you don't have some type information. And that's what we're going to kind of cover over the next couple weeks. And it's one of the trickiest parts of C and one of the trickiest parts of the course for a lot of people because you don't quite see the diagrams. So we're going to see lots of diagrams today, and we're going to dig into some of the details. All right, so let's get going. So let's go right ahead here and talk about pointers. Okay. If you were in CS 106B or if you took a C or C++ class, you have probably learned about pointers before. Okay, so you probably also remember them as being a little confusing maybe, and in some cases not really that useful because you could do lots of things with references in C++ and so forth. If you're coming straight from a Java background, you may never have ever heard of a pointer. Okay, because Java doesn't have pointers. Well, Java has pointers, but they're all hidden from you. They're hidden enough that you can't actually get to the pointers themselves. It's just not available in Java. That's for safety reasons. It's so that it's harder to hack things in Java because you don't have access to the raw memory. Whereas in C, look, you have the raw memory available to you. So that's how it goes. Now, on the MIF machines, pointers are 8 bytes long. They're 64 bits, okay, and they generally, well, they will refer to a memory address. Turns out that we only care about the bottom 48 bits of them, but we have 64 bits available in the pointer for the address. Okay? That gives you a giant address space, which means you can refer to lots and lots and lots of memory with 64 bits. And that's the way we've kind of come to when we get to 64-bit machines. Okay, the thing about pointers is that they're just numbers. A pointer is just a number. It's a 64-bit integer, and that's it. If you start thinking about, well, what, more details about the pointer than that, you'd start with that. If you were in 106B with me, you'll know I flashed up the PowerPoint slide that said that a pointer is just a memory address like every single day once we learned about them. Okay, that's all it is. If you're confused about something, go back and go, wait, if all I have is a memory address, what does that mean? And you'll go from there. Okay? All right, let's look at some examples. Now, I've shown you some of the details of this kind of diagram before. Okay, this diagram here is going to be memory address in the bottom, and then going up is increasing memory addresses. Okay, so let's take a look at this program here and just see what we've got. I am saying that int x equals 7. What does that mean? It means I've declared a variable, and that variable has the value 7, and that 7 has to be stored somewhere, okay? And it's actually stored somewhere in memory, okay? Generally, turns out, and we're going to get to this much later, it's not actually stored in memory if it's just the variable. It actually ends up being stored in what we call a register, which is much lower level, and we'll get to in a few weeks. But let's say we do want to get the address of that. Well, once you decide to take an address, your value does have to be in memory. So how do we actually take that address? Well, we use this ampersand character here to say, give me the address of this thing. And you can do that for almost any variable in C. You can say, give me the address of that. And the compiler will be forced to actually put the value in memory and give you an actual address for it. Okay? Now, if we go and print out the actual value of x, well, this should look pretty familiar. It should just print 7. Okay? We can also print, before we go on, notice what the type of the pointer is. I have said int star and then xptr, just to call it pointer. It doesn't have to be called xptr. But the type for a pointer is the type that's underlying that thing with a little asterisk on it, which says it's a pointer to that thing. So x pointer is a pointer to an integer. How many bytes is it? 8 bytes. All pointers are 8 bytes. Whatever happens to be in what's pointing to, it doesn't really matter. The pointer itself is 8 bytes long. Keep that in mind. Okay? All right. So if we print the address of x, it will give us some address. And by the way, the %p will print an address in hexadecimal for you if you pass it an address, if you pass it a pointer. And so we get this printout here of 0x7ffeea3c948c. We don't ever really care about the specific number that is. We just know that it is a number, and it is a 64-bit number that is the pointer. Now, that number is where x resides. So you can get to x by dereferencing the value. If we do this, if we say asterisk x pointer, that's how you go and get what the pointer is pointing at. Okay, so you type asterisk and then the pointer name, and that says go to where that location is, get that value, and give it back to me. That's how it works. Yes, you declare pointers with the asterisk, and you also use the asterisk to dereference. It's an overloaded thing. It's just a syntax thing you got to get used to. Okay? All right. So far, this should be mostly review if you were in 106B. So far, so good. Okay? You can get the address, and you can get the value by dereferencing. You get the address by the ampersand, etc. Okay. So sometimes, and in 107, we will have pointers to pointers. Now, this is always glossed over in 106B and saying, yeah, this exists, but don't worry about it too much because you'll see it in 107. Well, now you're here. We're seeing it now, okay? A pointer to a pointer just means that you've got a value that's a pointer. It is pointing to a value that is also a pointer pointing to something else. So it's 2 levels of indirection is what it amounts to. Okay? Let's take a look at this program and see if we can kind of walk through what's going on. Okay, same thing here. I'm saying x equals 7. Okay? X is equal to 7. And then I'm saying, okay, I want an x pointer, an int pointer called xptr, which I'm going to get the address of x. And then I'm going to have an x pointer, I called it. Seems a little silly name, but I call it that, which is the address of xptr. Notice the type. The type is an int pointer. It can't just be an int pointer because the thing it's pointing to is not a 4-byte int. It's actually an address, which is an int pointer. So it tells you that it's a pointer to a pointer that itself is a pointer. So, and that's kind of weird to say a million times, but that's the whole idea. Okay, so you have to deal with that when you do that. Now, let's see what we can do with this. All right, same thing. We can print out x. That's going to print 7, like down there. Okay, we can print the address of x by doing just xptr, because that's what we got the address in. That prints out some address. Okay, we can get the address of the pointer to the point. We can get the address of the pointer to x by printing out the address of x pointer. We can also get the address of x by dereferencing x pointer once. Does that make sense? You say asterisk x pointer, and that gives you back the address of x pointer. Okay. You can also get the value of x through that x pointer by doing a dereference twice. Now, why am I hammering this? Like, why am I like being slow and like very explicit about this? Because you will see this very, very often in this class, and you have to understand it. So if we say asterisk x pointer, what does that mean? It says, okay, x pointer is a pointer to a pointer. Dereferencing it once takes us to this value. Dereferencing it twice takes you up to the actual value 7. What questions do you have so far on that? Trying to be very explicit about it. Yeah. If you double dereference a single pointer, good question. Let's say you said asterisk. Let's say you said, by the way, my tablet is broken, so it's completely broken now, so I can't do it. So if you did asterisk x p, I'm trying to do this with my finger, my hand here, t r, oh man, this is like ugly. If you did that, that gives you 7, right? If you try to do another asterisk on there, asterisk that, you would do this. You would go to 7, and then you'd try to dereference 7, which means you're treating it as a memory address. You know what's at location 7? Nothing you can have access to. Location 7 is completely owned by the operating system, and you don't have any access to it. In fact, if you tried to do that, it would segfault. The good news is the compiler would probably warn you about that and say, you really can't do that because you can't dereference an int directly. It'll probably let you, like it'll be a warning, not an error, but it won't, when you run the program, crash. That's what happens. Good question. What else? Yeah? Yeah, good question. If the thing, the underlying thing is a long, let's say, then the pointer to that long is a long pointer, and the pointer to that long is a long pointer pointer. It's not just an int pointer. It's always the farthest away type that you're referencing, right? That's the idea of that, right? Yeah, it does take a while to get your brain wrapped around some of these things. The first couple times you see them. Yeah. Yeah, you could keep chaining pointers together. Once you get to like more than 2, it starts getting really weird. Like 3, I've seen 3 used legitimately before for like 3-dimensional space, where you're trying to kind of refer to a cube or something, like a position in a cube. But otherwise, you really don't want to go too far in that. It gets a little ugly, and it also just gets hard to process in your brain and figure out what's going on. You could. Yeah, you could. Okay. So, what does the following code print out? This is a good example from just what we talked about here. Okay? So, if we have this code, well, what's happening here? I'm declaring a char string. Okay? We're going to get to what this actually means in a little bit later. CS107. And this, by the way, is a pointer. Right? Why is it a pointer? Because a string, as we talked about last week, is defined by a pointer to its first element. Okay, and then all the elements go from there. So str is a pointer to a string, and str pointer pointer is a pointer to the str variable. So does it make sense that str pointer is a double star in this case? Because I've said, give me the address of the thing that's pointing to that string. That's why it's a pointer pointer. And what happens if I double dereference that? What do I get? Yeah. C. Okay, why? Because the first dereference takes you to the string and says, okay, this is another address. If I dereference a string, well, the string points to a, let me write this up here. By the way, somebody asked if I could put like everything on the screen when I'm drawing. I can't do that so easily without the tablet, but sorry about that. So if you have a string that points to like A, B, C, and let's make it correct so it has the little zero there. Okay, that's a char pointer. Okay, and if you dereference a char pointer, that gives you a char. If this is a char pointer, and you dereference it once, it gives you a char. Which one does it give you? It gives you the one it's pointing at. That's it. Okay. How might we print out in this case? How might we print out the B up here? There's actually we're going to get to that in a few minutes. But what do you think? Yeah, you could do str plus 1 and dereference that. That would actually give you the second character in the string. Or you could do it the way we've always done it, which is just str bracket 1. Those are equivalent statements. Yeah, question? Sorry, say again. Why does it? Oh, no, no, no. Pointers have to be pointers can be the type of thing that they're pointing at. That's what type they are. They're like a char pointer in this case. They are integers. So the pointer itself is a memory address. It's just a number, which is an integer. It's an 8-byte integer, in fact. But what does it point to? It points to, in this case, one character. Right? And the other thing we looked at before, it pointed to one number. Okay? That's the difference, and that's critical to get in your brain on this case. Question?
Can you then dereference string plus 1 to get, I'm sorry, not dereference, take the memory address for string plus 1 to get the memory address where the second character would be stored?
Sure. If you did ampersand, in this case, str plus 1, that would give you the address of the B. I'm sorry, you're right. Sorry. That's just the address. Thank you. That's the address right there. If you want to get that, you could do that, and then, well, that wouldn't even work either probably. But you could do that. That's the address, yes. You don't need to actually do the ampersand in that case. Yeah, thank you for correcting me on that. That makes sense? Yeah. Stir is what? It's a number in memory that happens to be that location. Stir plus 1 is that location. Stir plus 2 is that location. Okay, we're going to get into more details about why that's important a little bit later and how it's not exactly always 1. We'll see why in a few minutes. Okay. Any other comments? Yeah, question? Where is the data type of the pointer stored? The compiler keeps track of it. That's all there is to it. It's not stored anywhere. Just as you're building the program, the compiler goes, oh, okay, I know that's a char star, so this is how I'm going to deal with it. I know this is an int star, so I'm going to deal with it. But after the program's built, it's gone. Yeah. You'll see that when we get to assembly language. Yeah.
So if you were to just do, like, assign mystery to star string thing, would it just give you the string?
If you were to say mystery, sorry, say that again?
Mystery equals just one star.
Well, yeah, okay, first of all, if you were to do that, it would be a compile time error because you'd have to have a different type for mystery. It's not a char anymore, it's a char. Asterisk, in this case, asterisk, here, let me get this right. Asterisk, and then stir pointer is what kind of thing? A pointer to a char. So you'd have to say char like mystery pointer equals asterisk stir ptr. Make sense?
Yeah.
Yeah. Okay, good. Yes, thank you. Thank you. Yep. Anybody else back here? You had a question? No? Okay, yep. Yeah, the char is one character, and that's all it points to. It's an address of that character. That's the address. One away from that is the B. One away from that is the C. One away. You got to do some arithmetic to get to the next ones. It's just an address pointing to that A. B is the next one. C is the next one. D is the next one. Good question. Okay, let's move on. Why do we care about pointers? Like, why do we actually use them? Okay, pointers are references. Okay, why are they references? Because it's one number that refers to some other place. It refers to some place in memory. Okay, and we're going to use that very explicitly when we get to arrays in a few minutes. Pointers let us write functions that modify the values. Okay, that are created somewhere else. So you pass a pointer into a function, and the function can reach back and modify that data based on the pointer. That's very nice. Okay? Pointers allow us to deal with big data structures very conveniently. When all you have to do is pass around one 8-byte pointer, that's really fast. If your data structure is a gigabyte of data, and all you need to do is pass around one 8-byte pointer, you don't need to move all that data. It's very fast. So that's important. Okay? Pointers allow us to reserve new memory during a program. In other words, you're inside a function, and you want to get a bunch of memory that is going to be used outside the function. Well, you can't just declare it like a variable because remember there's scope issues. You can't just say, you cannot say something like int x bracket 10 and expect that to be available outside the function because that's a local variable inside the function. It's No good anymore outside the function. Okay? So we're going to be using pointers to get values that we ask in a different way from the memory, using this thing called malloc, which is something that you will use. It's kind of like new in C++, if you're used to that. Okay? And calloc and realloc are kind of the other forms of that, and they do slightly different things. Okay? So that's another thing that pointers can do. And pointers will also allow us to refer to an element generically. So in other words, we're going to be able to pass a pointer around that doesn't tell us the type. All we know is it's a pointer, and that's going to enable us to do things much more generically than with the type. Okay, you lose information by doing that. We'll see that in a couple days. Okay, so that's why we do that. All right, let's move on to arrays. Okay, last week we talked about arrays being, like strings being just kind of a special array of characters, one after the other. You can have arrays that are not just characters. You can have arrays of a particular data type. Okay? How do you access the array? Well, it's exactly like we were just talking about. If you have some array, actually I'll do it on here. If you have some array, you can access it using either bracket notation, ARR bracket 2 means give me the second element in the array, or you can say asterisk ARR plus 2, which is this pointer arithmetic. Okay? What does that actually mean? It means that the compiler has to know how far away each thing is. Okay? We're going to see an example in 1 second about what that means. Okay? Arrays can behave like pointers, but they're not really pointers. Okay? They can actually decay into pointers. We'll see where that's the case. But you have to be very careful about when you use that and when you apply certain things to the arrays. We will see all of those details as we go along here. Okay? All right, here's another example, a program that we have here. Notice in this program, I have declared a short values array. In other words, it's an array filled with shorts. How many bytes are shorts? Do you guys remember? 2. Okay, so each number that I'm going to put in that array takes up 2 bytes of space. Okay? All right, now this is a shorthand way of declaring an array, by the way. You just put it in curly braces and you start numbering them. You just kind of list them all comma separated. Okay? So in this case, we have 1, 2, 3, 4, 5, 6 values in this array. They are shorts. Okay? And let's look at what the memory looks like. Okay, I've just made up the addresses down here. Those are not real addresses, but I just made them up. Notice that the first one that we put in here, the 1, is at address 80 in hex. If it's a short, it takes 2 bytes, meaning the next one has to be at what address? 82. Okay. And then the next one's at 84, and the next one's at 86, and 88, and then 8A, because 8 plus 2 in hexadecimal is A. So you got to get kind of used to that. Okay? But that's how the memory is laid out. Okay. Now, often we want to find out how many elements are in the array, and you can do that if you have an array. You can't do this if you have a pointer. This is where arrays and pointers are different. But you can do the following. You can say, you can use the size of operator, and I talked about this in the lecture from last Monday, so if you didn't watch that, this might be new to you. But the size of operator says, how big is this thing you're passing me, or you're trying to get? Okay? For arrays, size of gives the total number of bytes of that array. That's what size of does. It says, how big is this array? The compiler can figure it out because it's right there and it knows how big it is. So the compiler says, oh, okay, values is actually the total number of bytes. Okay. We can also do size of values bracket 0. Okay. Based on what we just talked about, what type is values bracket 0? It's a short. Why is values bracket 0 a short? We have declared values as being an array full of shorts. There's one, there's one, there's one, there's one, there's one, there's one. Okay? An array full of shorts means that the first element has a size of a short, which is 2 bytes. Okay. how big is this whole array? 2, 4, 6, 8, 10, 12. If we do size of values, and that's on the next slide, I think, size of values will give you 12 in this case. Size of value 0 gives you 2 bytes because it's the size of a short. When you divide the two, 12 divided by 2 gives you 6, which tells you how many elements there are in that array. Pretty clever, huh? That's how you do that. Yep.
So is that the size of, is that like more of a macro?
Yeah, size of is an actual operator that the compiler uses. It's not a function. It's not a. It looks like a function, but you can just say size of int without the parentheses, and it works just fine too. It's just an operator that says, hey, can you tell how big it is? Tell me how big it is now, and you got to be able to figure it out. Okay. So what does this do now? This actually prints out, okay, each value in the array, comma separated until the last one, and it prints a new line. Okay, and each one is 2 bytes long, and it turns out that %d will be able to figure out that it's a short in that case. Okay, all right. Arrays are not pointers. Okay, arrays behave like pointers. I'm going to keep stressing this because you got to kind of get the difference in here. Okay, arrays. There is no pointer when I say short values equals 1, -1, blah, blah, blah. There's just a value there that the compiler knows about and says, okay, here's where your array is in memory. There's no pointer to it, and that's the end of it. If you want a pointer to it, you can get it, but at this point, there is no pointer. Yep?
So it would give me an error if I try to dereference values?
It would, no, you can get it. You can get the address, but at the point of when you define this, there's no pointer. Don't worry about that quite yet. We'll get to the detail here, okay? But this is actually telling you that it's 12 and 2 based on what we just talked about there, okay? The compiler does the keeping track of where in memory this is. If you do ask for a pointer, then it does give it to you. We'll see that in a minute, okay? How it decays into a pointer, okay? All right? The reason I keep stressing this is you can't do what I'm just trying to do up here. Okay? You cannot do this. You cannot say int array 3. That's an array of 3 integers. How big is each integer in that case? 4 bytes. Start getting these numbers in your head, okay? You can't say that. You can say int a equals 4, and you can say, okay, look, I want the address of a. You can do that just fine. You can say I want the address of a, but you can't go and say array now points to a. Array is ARR is not a pointer. It's just an array in this case. So you can't set an array equal to some other value. You can't change the value of the array. Question? Yeah, good question. So the question is, could you start this and say, instead of int ARR3, you say int star ARR. You're actually not allowed to declare a pointer that way. It doesn't actually work. So you can try that, but then compiler will not let you do that. It'll give you some weird error about you can't do that with an array. You can't initialize a pointer with an array like that. Anybody else? Yeah.
If A were an array, could you just set like ARR equals A?
If A were a pointer. It is an array. No. Sorry, you can't say, what you can't do is you can't say ARR equals anything. You're not allowed to ever say reassign a value. You just can't do it. Yeah. You can't reassign a value. Yeah. Can you dereference ARR? Sure. You can dereference ARR, right? Because that turns it into a pointer and then gets the value for it. Yeah. Then it actually becomes, then you can actually do that. And so that's kind of what we saw before as well. Okay. All right. Lots of little details in this lecture that you kind of gotta get going here. And here's what the error is actually. Okay. It says int bracket 3 is not assignable. You can't assign an array. Okay. Reassign an array. Okay. You can assign array addresses to pointers. Okay. You are allowed to do this. You are allowed to say, okay, int ARR3 equals 1, 2, 3, and then you say ARR pointer equals ARR. That works just fine. Why? Because ARR pointer points to an int and the ARR array decays into a pointer in that case and says, okay, fine, I will give you that value there, give you the actual value. Okay, I know it's a little like, confusing the first kind of time you see it, but it gets there. So interestingly, all 4 of these will actually print the same thing as it turns out. If you say, print out ARR pointer, well, that's the address of the first character because we set it equal to the array. Great. We could say, print out ARR. In this case, ARR has degraded or decayed into a pointer. In other words, it's treated like a pointer in this case. This one works too. The address of ARR bracket 0. Well, isn't ARR bracket 0 the first address, which is what the array points to anyway? So if you say ampersand ARR bracket 0, you get the address of that same thing. And finally, you are allowed to do this. You are allowed to say ampersand ARR. Try to avoid that. It just looks funny and it's a little weird because ARR is already an array. You're allowed to do it. Try to avoid it, but it still works. So all 4 of those give you the exact same output when you print out. So far, so good? Okay. Question?
So getting the address of ARR produces the same output as ARR.
Yes, getting the address of ARR produces the same output as ARR. I know it's weird. It's the way C was designed. So that's why I'm saying try to avoid this form because it looks weird. Just say, look, I'm just going to treat it like a pointer when I'm getting a pointer value, an address of it. Okay. Just wanted to show that you might see that sometime. Okay. A pointer to an array points to the first element. I've kind of gone over this 100 times already, right? A pointer to an array points to the first element. Okay, you can use pointer arithmetic or bracket notation. Okay, and then you can change the value of the pointer if you have an actual pointer. Okay. Now let's see what this actually means here. Okay, if we say ARR pointer, in other words, ARR PTR, which we just set to be we got the value of the address of the first one from ARR. And we now say ARR PTR plus plus. That changes the value of the pointer to point to the next element. Now, that is exactly the same as saying the following. It's exactly the same as saying ARR equals ARR plus 1. In this case, is 1 plus 1 equal to 2? Or I guess I should say is 4 plus 1 equal to 5? Why am I even asking that? What is the address of ARR? Which address down here is it? This one right here. Let's just look at the last 4 digits. 9484. Okay. How big is each element in the array? 4 bytes long. Why is it 4 bytes long? Because it's an int array. Each integer is 4 bytes. With me on that one? Each integer is 4 bytes, meaning that the next one is 4 bytes away. So when you do ARR plus 1, the compiler says, oh, you don't mean ARR plus 1 byte. You mean ARR plus however long each one of the things in that array is. You've been doing this your whole programming career so far. If you said ARR 0 and then you said ARR bracket 1, like that, this one is 4 bytes away from this one, but you're indexing into it. The index is what we care about in this case. Okay, so that's the key there. Yeah, question in the middle. No, we'll get to you in a sec. Yep. Yeah, if you said ARR equals ARR plus 4, that would be 4 indices ahead, which would be 16 bytes ahead. The compiler knows this. How does the compiler know this? Because we told it the type. We said, oh, this is an int pointer. In other words, it's pointing to things that are 4 bytes long, so every time you increment it, it needs to go 4 bytes away. Yeah, so it gets a little bit hairy there, yeah, and then, yeah.
Two questions. One, does this work for all pointers, or
Good question. It works for all pointers as long as the compiler knows what the type of the pointer is. Later, we're going to talk about these things called void pointers, where the compiler has no idea what that underlying type is, and you have to figure it out yourself based on something you passed in.
And second question, what if you actually just wanted to add one? Is there a way to do that?
Yeah, if you just wanted to add one, and we can do that later, you do have to cast it to something that can be incremented by one. In fact, the only thing we have is a char star. You could do that if you really wanted to. You might not want to. You might want to, but you would have to do it that way. Question?
Before, when we were doing, like, you referenced it on the board with the star and the STR plus one.
Mm-hmm.
If you did without the parentheses, what would that look like? Would that be like similar to this?
Yeah, good question. Okay, bear with me on this. If you did asterisk str plus 1, right, that would give you the A, and then it would add 1 to the value of A, which happens to be, what is the value of A? I don't remember. Whatever the value of A is in ASCII, plus 1. Okay? That's what that would do.
One as in the number one, or one as in like having
The number 1, so A in this case, what is it? Anybody know what A is? 97. So A is 97. You say asterisk stir, you get a number back that's 97. Then you say plus 1, it gives you 98. That's without the parentheses. With the parentheses, what do you get? You say, okay, stir plus 1 is 1 byte away. It gives you back the B. Yeah. Play around with these in the code. You can definitely do that. Yep.
I just want to be clear that my understanding is correct. So you declare a pointer that points to the head of the array denoted by array, right? So it's going to be
Yes, you are declaring, by this statement right here, you are declaring a pointer to point to int, and it points to the first one.
Okay, so you then increment basically the memory address that is pointing to.
Yes, you're incrementing the memory address by however big the number is.
So then if you then read ARR element 0, will that give you back 2? Does that change?
Yes, it would. Yep, if you then, after this, said ARR pointer, not ARR, ARR pointer, PTR bracket 0, then, if I can, there we go, then you now have AR, now it points to the next one ahead.
And what if you read ARR to 0?
ARR has not changed at all. But it never changes. ARR is pointing right to that first one and will always point there. Okay?
So in the comments, do you mean ARR?
Say again.
Do you mean in the comment on the last line, ARR points to that?
ARR now points to the 2 over here.
But that's what we just said, that ARR is unchanged.
You're right. Thank you. That should be ARR PTR. That was your question. Sorry. If I have a typo, let me know that. Yes, that should be ARR PTR. Thank you. I'll change that on the slide. Thanks. Okay, let's move on to the next little section here. Okay, once we have pointers to arrays, okay, let's actually dig into that a little bit more, and let's practice a couple. Okay? If you're incrementing by the size of the type, always look at the size of the type before you move on. Okay, before you actually, like while you're trying to figure this out. So, here's a question here. ARR, same thing, 1, 2, 3, 5, 6. It is now an int pointer. Okay? An int pointer decays to a pointer when you do this, and if you say ARR PTR, that gives you the address 72780. What if we do ARR, what if we print out ARR PTR plus 1? What are we going to get down here? 784. And then plus 2 would give you 788, and then 78C, and then 780, and then 784, because you're just incrementing by 4. Okay. Let's try another one. How about this one? Again, I'm hammering this, and I'm like being very explicit about this so that you see how important it is to get this into your brain. In this case, what's going to be next if I do ARR PTR plus 1? 7, 8. Why is it 7, 8? Because it's 8 bytes each. Okay, well, how do you know that? Because you look up here and you go, oh, they're all longs in there. Even though the numbers I put in there look exactly the same, they're taking up 8 bytes each because I said, oh, they're each longs, and then I could make them bigger to fill in those 8 bytes. Okay, let's try one more. How about this one? Char array equals 1, 2, 3, 4, 5, 6. Can I do that? Can I put numbers in chars like that? Sure, why not? A char is just a byte, right? A char is a byte, and it doesn't have to be a character. It can just be a byte. So if I have 6, 7, 8b, what's going to come next? 6, 7, 8 C, and then D, and then E, and then F, and then 0. Okay, are we getting that? Like, that's the key to understanding a lot of this stuff. Always look at the type when you're doing this. Whew, that's a lot of stuff. Take a 3-minute break. Okay, I think that's been about 3 minutes. All right. So, now you know a little bit about arrays. Now you know how the compiler thinks about these things. You know how pointer arithmetic works. And pointer arithmetic needs to know the type so that it can add to the next index. It's just indexing into the array, and the type tells you how to do that indexing. Question? One hex digit, it's not one hex digit, it's 1 byte, which is actually 8 hex bit, or it's 8 bits. No, B to C is, B to C is 1 byte more. Because 8B to 8C is 1 byte away. Yeah. We're talking about, isn't 1 byte, it's one number is what it is. It's 1 number away. Don't talking about how big the number is, how many, each one refers to 1 byte, as you, just like you count 1, 2, 3, 4, 5, it's the same. Talk to me right after, we'll clear that up. All right. Pointers to arrays. We've kind of talked about this already, but let's actually think more about this, okay? If you have a pointer to an array, what does that actually mean? It means that you can get the pointer, the address, okay? It also means that you can actually refer to it by saying ampersand to get the actual the address, okay? And you can get the value by saying just the ARR. Okay, so this is the same exact thing as we saw a little bit earlier, okay? And it's exactly the same basic idea of here's an array. Now I'm using a pointer to refer to the first element in that array, and we can then print out the element like this. Now, take a look at this one little piece here. Asterisk ARR pointer plus plus. What is going on there? This is all about order of operations in this case. This is saying, we're going to unpack this. In fact, it's on the next slide here. This means dereference ARR PTR. That's what the asterisk means, and that binds very tightly to the variable. And it says, give me that value, and then increment the pointer itself to go to the next index. Okay? It does not mean add 1 to what ARR points to. In order to do that, you would have to put some sort of parentheses around this. Okay? You will see lots of things like this in C. It gets a little ugly because it's the first time you've ever seen it, and you got to unpack all this and say, okay, what's actually happening? Go back and try a program and actually see, right? These programs are all in the lecture 5 slides. Go run this and remember exactly what's happening here. Okay? Yeah.
Wait, so we first increment and then dereference?
No, you increment after. The plus plus means increment afterwards.
Okay,
Okay, you dereference ARR PTR, and you get the value. Then you increment ARR PTR.
so even though what outside, if the dereferencing happens first, then why is that different from writing in the parentheses?
In this case, it's saying, well, because in this case, the plus plus refers to the pointer, not to the value you've gotten. In this case, the plus plus refers to the pointer, not to the value that you got from that pointer. That's the difference. Question?
So is that the same as this, the big one, is that the same as just having AR, PTR plus plus, but if the star is irrelevant?
If you left off the star and said ARR PTR plus plus, that would increment the pointer by 1. Well, by the size of the type, right, to the next index. But that's what it means. Yep.
If you were to make the order of operations explicit, how would you write the
Yeah, like this, right? Like that's how you would do it. You'd say, okay, look, if I wanted to increment the actual value that I got from the pointer without incrementing the pointer, I'd have to put parentheses around it like that. Yeah.
So the thing it prints out on that run is like the first one that it got, and then if like the next one.
Yes, yep. In this case, it prints out. In fact, I think, I don't have it here, what it prints out. It prints out all the values one at a time in this case, and it increments the pointer each time. But it prints out the value, increments the pointer. Next time through the loop, pointer is updated, so it prints out the next one, increments the pointer, prints out the next one, increments the pointer. Good. Yeah. If you put the plus plus before the star, I'm not sure actually what would happen there. You'd have to try it out and see. But you'd have to try it out and see. I think it would probably it would probably increment the actual value. It would probably increment the value it got back because the star is next to the ARR PTR. Yep.
If you put the plus plus between the star and the R pointer, then that would do the same thing except it would bring the loop shifted by one.
Yeah. If you put the star before the ARR PTR, it would increment ARR PTR and then dereference it. Because plus plus ahead of time means do the plus plus now. Plus plus after means do it after you've already gotten the value. Okay. Yep. Right here, the first time through the loop, you would get 8 right here. And then ARR PTR would now point to the next one. The first time through the loop. Second time through the loop, ARR is now going to point, ARR PTR points to the 2, so you get back the 2, and then ARR PTR points to the 7. I know, you thought this stuff was like just a little code. Yeah?
So why does it even like, it dereferences it, but then it goes back to ARR pointer?
The dereference happens first. In other words, it says, hey, give me the value for ARR PTR. Give me the value that it's pointing to. Okay, it's the 2, and they're 8 in the first case. And then it says, oh, what else are you doing? Oh, I'm also updating the plus plus there. I'm also like updating the pointer to the next one. Now, you want to see something really ugly? Bear with me. If you wanted to do it in one line, right, you could, oops, you know what, I think I accidentally, oh no, there we go, there's 2 lines. If you wanted to do it in one line, you could do that, right? If you wanted to, like, combine the 2 that I'm doing, like, combine the 2 there, right? Did I do that right? It doesn't look right. Yeah, that would work, right? So it's ugly. Don't do this. Like, scratch this out and don't do ugly code like this. Okay? You want to do clean code. And you want to do clean code like so that it doesn't confuse people who read your code. Yes?
Is there a way that you can actually change the 8 in memory, like increment 8 in memory, keep in mind?
Yeah, you could do that. If you do, let's see. Yeah, we're going to see how that works too, but you can do that as well. You can say, look, the value there, if you do the dereference, the parenthesis things, you could do that. You could increment it in place. That's how it would do it. Okay, let's move on. Okay. All right. More examples. So remember that size of thing I talked about? And this came up in the 3-minute break. Somebody came up and asked about this. When you pass an array into a function that expects a pointer, it decays into a pointer, and you've lost all information about how big that array is. Okay, it just happens that way. You've lost that information. So take a look at this function. When we say size of test and we pass in an int array, it really means int pointer. When you pass a pointer or an array into a function, it decays into a pointer even if you put the little brackets on there. It's exactly the same. Okay, so what does this do? Well, let's look at this. We have an int array, okay, and we say, okay, look, int array 2, bracket 2 prints out 4 because that's 0, 1, 2 away. Asterisk ARR plus 5 says, okay, 0, 1, 2, 3, 4, 5 prints the 9. That's dereferencing it and after doing a little pointer arithmetic. Okay, we can set the value of the third element by saying ARR bracket 2 equals 42. That's allowed, right? If we say size of the array in main. Okay, what's going to come out when we say size of array? Well, it's going to give you how many bytes there are in that array. How many bytes are there? Well, there's 1, 2, 3, 4, 5, 6 things. Each thing is 4 bytes long, so it had better print out 24. And it does. Okay. Now, you pass that array into a function, and you say, oh, fine, I'm going to pass the, I'm going to call this function size of test, ARR, and I'm going to pass that into my here, and I'm going to say, what's the size in the function? What does it know about this? As far as it's concerned, it is an array pointer. How big are array pointers? 8 bytes. So when you say size of that pointer, it says all I know is how big the pointer is because that's what you've given me. Therefore, I'm going to tell you that it's 8 bytes long. That's the weirdness as far as passing pointers around. Yeah, Jayla? If you pass an array into a function, you can access all the elements in it. Like that's, yes, you absolutely can. Unless you do it as const, we'll see it in a minute. Yeah. Somebody had a question over here. Yes?
Is there a reason why you would want to use an array as a pointer rather than just declare
a pointer and map it to the value of the array and then pass that instead?
Well, it's easier in this case. The question was, why would you want to do it this way? Well, first of all, if we're going to declare a bunch of memory, we have to do it this way. You can't do it at just a pointer. So you're going to need the array to begin with. And then if you're trying to pass it in, you just pass it as you pass ARR, and it goes, and the compiler goes, oh, okay, I'm going to decay it into a pointer and be done with it. That's all.
Basically, you don't necessarily care about the size of the array.
It's not just if you don't care about the size. You're probably going to write functions where you actually explicitly say, oh, and by the way, here's the size. So, or the size of each element anyway, at the very least. Question then back here. Yep.
So if the compiler knows how much memory is allocated for an array, if you try and go outside of that array, so for that example, you try and do
Yeah.
ARR6,
Yeah, if you try to do ARR plus 6 or ARR bracket 6, yep, the compiler will say, be my guest. Yep, the compiler has no business, doesn't care at all. It says, you know what you're doing. It might give you a warning in the array part. It might give you a warning, but odds are it'll just go, you know what you're doing, hopefully. Okay, Aaron, back here and then, yep. You had a question in blue out there. No, okay, back there.
If in the declaration of the function you did int ARR and then bracket and a number in that bracket, would that indicate the size of the array?
That would, you could put a number in here, yes. The nice thing about not putting the number is you can add another one to it without updating the number.
I meant in the declaration of the size.
Nope, up here it ignores it. Ignores any number up there. Yeah, just completely ignores it. Yep. Aaron. Right. This array looks like an array, but really it's just a pointer. It's kind of a syntax thing. They just say you can declare it as either a bracket or a pointer, and it's exactly the same. But it ends up being a pointer, and you just got to know that. Yeah. Okay. Look, next. In size of test, you don't know that there's only 6. In fact, you would, if you wanted to access those, you would have to pass along more information. You have to pass along that information. Yeah. Good question. Yep. No, you can't ever pass an array without the function taken as a pointer. Well, there is one, if you pass it inside a struct, it will do that. But we're not even going to worry about that in this class. But otherwise, no. Yep. You could do int ARR, you could do int star ARR. And that would be the same exact thing. It would mean exactly the same thing. Yep. Yep.
So what you're saying up there on that slide, is that kind of like a generalization of what we were saying about assigning an array to a pointer? Because like, that's kind of like a function, like assigning, like the assignment function.
We're not really assigning anything in this case. We're just passing in the value of the pointer of the array, which decays into a pointer, and you get that value. That's really all it is. Don't think too much more about it than that. What's that? Yeah, you absolutely can. Sure. Yep. Right. The only situation you can do that is inside a struct, which we're not going to worry about. Can't do it any other way. far as I know. Yep.
Once we pass the array to the function, right, with the pointer, we still access the third element of the array.
Yes, you can access any element of the array. Once it's up here, remember, with a pointer, you can still access as far away as you want, and the compiler doesn't care. It thinks you know the best. You know what you're doing. You can use brackets, and it'll still do it, because it knows the type. It knows that it's an int pointer, so it knows how big each one is. Yeah. Are there linked lists in C? There are, and you have to do a lot of this kind of low-level stuff to make them work. Yeah, it's kind of ugly, but you can do it. All right, let's move on. Okay, I already showed you this is the bracket notation or pointer notation. You can do either. Okay, so that's they are equivalent as far as anybody's concerned. They're actually equivalent. It's just syntactically different. Those are exactly the same thing. Okay, all right. Arrays are passed by reference, and this is like the first thing I said about why we use pointers, right? Arrays are passed by reference, meaning we just pass along that address, and therefore you have access to all the pieces in the array. You don't necessarily know how big it is. So notice here, when I wrote a little scale function. Okay? What does the scale do? It takes an array and it says multiply each one in that array by some factor. I had to pass in the number of elements. Why did I pass in the number of elements? Because by the time it gets to the function, it has no idea how many elements are in that array. No idea. So you have to pass it in there and you have to say, okay, fine, only print out up to the number of elements. Otherwise you risk buffer overflows, and otherwise you'd have no idea. So you have to pass that information when you pass along a pointer or an array. Okay? Otherwise, you can't deal with it properly. Yep.
I think you might have mentioned this before, but why are we using size underscore t as the type for the number?
Size underscore t is just an unsigned 64-bit int, and it generally refers to how many things are in various things. So I like to use it because it's unsigned, number one, and number two, it's as big as you ever need. Yeah. Okay. So let's move on. All right. Okay. If you do, now, when you pass things by reference, that function gets access to your data. What if you don't want the function to change the data? Or even more importantly, you want somebody else using your function to know that your function isn't going to change the data? You can declare them as const. In other words, you're saying a const long a bracket, or a const long asterisk a, exactly the same thing, means that inside the function you are not allowed to update the values in that array. The compiler will stop you from doing that, unless you cast it, but that's a different story. Okay, the compiler will not let you change the value of that if you declare it as const. So if you're just trying to use the values, it's nice to do that. We saw that with the string functions last week. We saw lots of those string functions. You pass in the source as being const. Why? Because that tells you that, oh, okay, I know that my string is not going to get modified in any way. Question in the back there. No? Yeah. It's still passed by reference. It's just the address. It's the address of the array. Yep, exactly. Okay, anybody else? Yeah.
If that doesn't know the size of A, how does it know what parts or what bytes are?
It does know that each one of those numbers in A is a long, and I've told it that there's that many elements in there. That's how it knows. So it knows that each one is 8 bytes away because they're each longs, and I've said, hey, here's how many there are. Yep. Okay, good. Yeah. The compiler enforces that, yes. The compiler does the enforcing. Yeah, it's just to keep you honest, basically. Yeah. Okay. So, good questions. All right. You know how we talked about strcpy the other day? There's another one called memcopy. Memcopy is just like strcpy, or it's just like strncopy, I should say, where it will copy the number of bytes you tell it to copy. Now, it will always copy those bytes. The issue with strcpy is it stops at the end of the string, which is always a 0 byte. But what if you have zeros in your memory that you want to copy? There's a different way to do it. You use memcopy. Pretty easy to use. You say, give it a destination, you give it a source, and you give it a number of bytes. Now, there's this weird pesky void star. For right now, all you need to know is any pointer works. As long as you tell it the number of bytes, it's going to say, I'm going to copy that number of bytes. Okay? That's all that means. Okay? One thing you do have to know about memcopy. You cannot overlap the source and the destination, otherwise you get undefined results. Now, why would you ever do that? Let's say you've got an array and you're trying to move this part of the array into some other part of the array, and they might overlap or something. Or like the two parts might overlap, like some parts might overlap the other part. You're not allowed to use memcopy for that. You use memmove, which is the other one. We'll get to that next. Here's an example of memcopy. Now, notice what I've done here. Okay, I've got an array. Okay, I want to copy that array, so I need some place to put it. You're responsible for having space to put that array into if you're going to make a copy. So I'm going to get the number of elements. Now, I'm doing this in a little backhanded way just so that you see how you normally end up with this. Let's say you just had the number of elements. I am declaring a destination array that is how big? It is the number of elements times the size of an int, and that gives me how many total bytes. How big is an int? It's 4 bytes. How many elements are there? In this case, there's 5. 5 times 4 gives me 20 bytes worth of space, which is exactly how many bytes I'm going to copy. Makes sense? Hopefully that makes sense. And then if I do memcopy, I'm saying, okay, the destination comes first, the source is what I'm copying from, and then I'm passing in the number of bytes. Same exact calculation. Okay? Same exact calculation. Okay, beautiful. Yes? Well, because you need to know the number of bytes. Memcopy says how many bytes are there. If I know how many elements there are, and I know how big each element is, I multiply the two together to get the total number of bytes. That's the difference. Yeah, okay, you could have said this in the destination array. Sorry, you could have said size of source. But I'm doing it this way just to show you the way you'll see it often, which is with this times the size of int. Does that make sense? That you could have done it with just size of source. Yes. Is that your question? Okay. That you could have done it that way. I wanted to explicitly not show you that way in this case. Question in the back. Because it doesn't know what the type is. It doesn't know that it's a type of int star, for instance. Because remember how we said it's a void star? That means you lose all information about the type of thing that's in there. That's what it is. Yeah. Yep. Whoops. Yes, that is to know, that is explicitly, when we did this right here, that's to say, okay, I need to have an array full of enough bytes to put the copy. If you passed in any other pointer, it would work, but it might crash. Like it would copy the bytes, but it might crash. But you need to be responsible for that. Question? Yes. Well, it would work. If you had said size of SRC, yes, that would work. Because it can count that. But I'm explicitly not doing that because you will more often only have the number of elements and only have the size of each element. Bear with me on that. You'll see why that becomes useful soon. So yes, you're right, but that's not the important part right now. You're absolutely right. Yep. In this case, int dest n elements time, but no, in this case, let's see. Oh, you know what? You might be right on that. I think you're right. I think you're right on that. In this case, you're saying because is that what everybody's question was? Probably all you guys are questioning. Yeah, you're right. In that case, you're right. Yep. In this case, you actually only need to know the number of elements in that case. Yes. Down here, you need to know the actual number of bytes. So yep, I'll have to change that. Thank you. Sorry for the people who are asking that same question. Right. That's absolutely right. Okay. It actually works in this case because I gave way too much space. Yep.
So the function signature of memcopy says that it returns a void pointer. So what does it return?
It returns the destination. So you pass it and it returns it back to you. That's all it is. Okay. All right. Let's move on to memmove. Memmove is exactly the same, except that now you can have overlapping parts. Okay, that's exactly the same, and now you have overlapping parts. So let me show you what I'm doing here. I probably did the exact same problem here. No, I didn't, because I actually copied over in this case. All right, in this case, you say int array equals 1 through 5. Number of elements, we still get the number of elements. Now I'm copying from ARR into ARR from ARR plus 2, and there's some overlap there if I'm copying 3 elements. So in this case, you have to use memmove. Now, bottom line is, just use memmove. If you try to use memcopy and they're overlapping, it might break, but memmove will always work. It's a little bit slower sometimes, but like so much slower that unless you're like super fine-tuning it, you don't never need to worry about that. Question? Yes. Thank you. Why am I still using memcopy? Good point. I will change that. I think that was probably a copy paste error. Hang on. I'll change it. I will update it after class. Okay. So where were we here? Here we go. Okay. So yes, it should be memmove in that case. Yep. All right. Question.
Can you say one more time what the difference is between memcopy and
Memcopy, you're not allowed to have overlapping areas. Memmove, you can. Yep. Good. All right. Yes.
I'm sorry, what exactly is overlapping?
Overlapping means that, let me change this to memmove so that it makes sense. But what it means is, look what this array looks like, okay? This array is 1, 2, 3, 4, 5 in memory, right? So it's 1, 2, 3, 4, 5. And what am I doing in that memmove function? I'm saying move, if this is ARR, isn't this ARR plus 2? And I'm saying move 3 elements from here to here, meaning that this part's actually going to overlap. What it's going to do is it's going to move the 3 to here. Whoops. Move the catch, huh? Move the 3 to here, and then, sorry, the 3, and then it's going to move a 4 to here, and then it's going to move the 5 to here, and there was overlapping space. Make sense? Okay. All right. All right. Pen top. All right. A couple things we have to talk about that we didn't get to last week because we hadn't quite learned enough about some of this stuff. If you're declaring a string as an array or pointer, you get 2 very different behaviors, as it turns out. If you say this, char star s1, okay, if you say char star s1 bracket bracket, that declares an array with this, what we call string literal. It puts the end 0 on there, and you can modify it. If instead you say char asterisk s2 to give me a pointer to that, and you say string literal with pointer like that, you're not allowed to modify it. It's just a weird C thing that says if you, by doing this first one, you are saying I am using this string to initialize this array. If you're doing the bottom one here, you are saying I am using this, I am getting a pointer to this string which lives in memory that I'm not allowed to touch. Why is that the case? Well, that's just the way it works. So just know that if you try to modify that, you will, if you try to do this, s2 bracket 0, it would crash. And it would say, nope, can't do it. Yep. No, if you do size of s2, it would say 8, because it's 8 bytes. If you do size of s1, it would tell you, I think size of s1 actually would give you how big the string is, I believe, because it knows right at the beginning. I think so. Okay. All right. Okay. Here's the actual example of how it actually crashes. It's exactly the same thing I just wrote up there, and I said string literal crash. That's what I called the program. And it says, oh, sorry, I'm just going to do it. If you look at GDB, over here, what does it do? It says, okay, I'm starting the program, I'm running it, and then it's going to crash right at that line. It says, I can't modify that memory, so your program's done. End of it. Okay? All right. This came up a little earlier. Be careful when you dereference. Okay, well, first of all, you can walk right off the end. I'll get to that in a second. You can walk right off the end of your array. When you dereference an array or a pointer, when you dereference a pointer, it had better point to something that is memory you own. Because if it doesn't, like if you try to dereference null, it gives you, it segfaults on you. Why? Because you don't own the 0 memory address, and it says, sorry, your program crashes. If you try to dereference some random address, then you can do that. Here's a problem I have right here, deref problems. In fact, I'll actually show it to you here. Deref problems, okay? And if we do deref problems, it asks for an address, or it just takes an address. 0, maybe not, hang on. How about, there we go. 0x123455. Is that a memory address that we probably own? We probably do not own memory address 0x12345. And what happens is it segfaults, right? We probably couldn't think of an address that we own in order to make this program not segfault. Okay, if you try to do 0, same thing, a dereference 0, it says, look, I can't get what's that value. So you have to be very careful about that. Okay? You would have seen this when you did in CS106B if you were using linked lists. You probably had lots of segfaults because you forgot to dereference, you forgot to check if your pointer was null before dereferencing it. I'm sure that never happened to anybody in here. Yeah?
What exactly is a segmentation fault?
A segmentation fault is the runtime saying, oh, you're trying to access that memory you don't own? Goodbye. That's what it means. It says you're trying to access memory outside of an area that is designated for your program. Yeah, and it can be, and it's lots of the memory. Yeah. Is there a way to know what memory you own? Yes, keep track of how your program is being written. Otherwise, don't just try to do random pointers and things like that. Now, you can write a function that expects a legitimate pointer, but you have to make sure that you're the one passing the right ones in there. Remember, if you pass a null to strcpy as the source, it will immediately crash. And you're going to get, and in GDB, it'll say strcpy crashed. And you're going to write something on Piazza that says, I think there's a problem in strcpy. And we're going to come back and say, no, it's actually your problem because you passed a pointer that's not legitimate. Yep. This is the big question. The question was, what determines what memory you own? You own this memory called the stack, which is a certain amount of memory that you're given. And then any memory you request from the operating system using malloc, you also own. But we're going to get to that next week, or rather on Friday, actually. Yeah, good question. Yes? Good question. Stir2 unsigned long. You're going to actually practice that in lab this week, I think. Yeah. Stir2 unsigned long. Okay. All right. Couple more minutes. As I said, your program will not check and say, hey, your array is out of bounds until it segfaults. If you try to do this, so notice this program here. I've said, okay, I'm going to define nums as 10,000, and then I'm going to make an array of 5, and then I'm going to try to print out the 10,000 numbers in that array. Well, guess what? My program actually had access to a whole bunch of that memory, mainly because it's on this thing called the stack, but it eventually segfaulted. It said, oh, look, you're trying to print way too much memory, you're done. And it segfaults. So be careful. The compiler didn't give any warnings when I compiled this. The compiler said, sure, go right ahead, do whatever you want. And that was it. Okay? All right. Okay, last thing. And we're going to hammer this as we go along in the next couple weeks. One of the trickiest things for CS107 students to know is to get used to this memory idea. Now, we did this earlier where we said, what's the next address, what's the next address when you're incrementing a pointer. But let's just look a little bit more in detail, and then we'll come back to this and come back to this and come back to this, okay? All right. All right. How many bytes does each int take up? We already know this, hopefully. 4. Okay, each int takes 4, 4, 4, 4, 4 because I've declared an int array. Okay, all right. If we wanted to write a swap function, in other words, if we wanted to write a function that would swap 2 of the numbers in that array, we could do that with this little function right here. Okay, give me an array pointer, give me the index of the first thing you want to swap and the index of the second thing you want to swap, declare a temp variable. Okay, where's the temp variable? It's at array plus index x, or rather, that's going to get the value at array plus index x. We're dereferencing it. Could have used bracket notation. Okay, and then we're going to set x equal to y, its value. Get the value from x, put it into y, or y, put it into x. Then we're going to get the temp value and put it back into y. It's a swap function. Could we do this swap function using memcopy or memmove? Sure we could. Your next question is going to be, why would we care? But let's bear with me on this. We could do this with memmove. We could say, take in the array, take in the index and the two indices, and then use memmove to actually move 4 bytes from the original x into temp, from the original y into x, and then from temp into y, using those 3 memmoves there. Do you see how I used size of int to tell me how many bytes I had to move? How do we know how many bytes? Because it's an int, right? We know that we're copying an int. Now, you will see this on the midterm. You will see this on homework assignments. You will see this like for the rest of the time in this course. You have to get used to what's going on here. What is happening? It's taking 4 bytes from, in this case, let's say I was swapping the 8 and the 14. It's taking 4 bytes from 8, putting it in some temporary variable, taking 4 bytes from 14, moving it down here from this memory address, not from the 14. It's taking the 4 bytes that mean 14 from this 9490 memory address and moving it to 9484. And then it's taking the temporary one and moving it into 9490. Get how that works a little bit? Okay, I'm going to leave it there for today, and I'll see you guys Friday.